Hi, in this video we're going to take a look at the January 2012 Higher Paper 2 question 22. And as you can see, it's a problem about vectors. The very first thing we're going to do is expand out that diagram so we can see it a bit better about what's happening. And you'll notice we're told information in the problem that OD is equal to A and OR is equal to 3B, and they actually show you that on the diagram as well. Now, when we are solving the rest of this problem, we're only going to be able to use these two vectors. There's no other diagonal vectors that we can use, so we need to bear that in mind, that all our answers will be in terms of A and B. In other words, horizontal movements followed by vertical movements. Okay, so let's have a look at how that works out. Now, the first bit we're asked to work out the vector OQ. That's from here to there. Now, we don't have any diagonal information, but that doesn't matter. In vectors, what matters is where you start and where you end up. It doesn't matter how you get there. Now, I could go this way and along there, or I could go this way and up there. Doesn't particularly matter which way I go. I will still end up at the same place and I'll end up with the same vector. Now, let's have a look at how that works out. Now, we've got the first step here, which is to move along OD, which is vector A. Now, that's 1/3 of OP. We're told that in the question that D is the point on OP such that OD is 1/3 of OP. So we've moved 1/3 of this direction here. So we can move another 2 steps. And that would be 3A altogether. We've moved 3 steps that are all exactly the same size in the same direction. So that works out as 3A. And then we move vertically to get to the point Q. We've finally arrived at where we're supposed to be. Now, it's important to recognise that vectors that are parallel to each other and the same length are the same vector. So in actual fact, what we've got here is 3B, just the same as we have over here. So effectively, we've moved 3A along here and 3B up there. And that gives us this vector movement here, which we can factorise out to get 3A plus B. That's the simplest form of this vector. Notice if we'd taken the vertical route, we'd have 3B, and then we'd have had to move along here, which is parallel to this vector down here, which we've now worked out has a size of 3A. So it would have been 3B plus 3A, which is effectively the same as what we've got here. Now we have to work out the vector OE. Now, we don't actually have, again, any diagonal information. It's all going to be done in terms of the vectors that we've got. So let's have a look at what information we actually have. We're told that E is a point which is 2/3 of the way along OQ. Now, we already know OQ. We already know it's this 3A plus B. So in order to find OE, we need to find 2/3 of OQ. And OQ, as I've said, we already know is 3A plus B. So we're finding 2/3 of that. And the 3 will just cancel out with the 3 to give us an answer of 2A plus B. And that's our answer for that particular part of the problem. Now, clearing things off, let's have a look at the last bit. We have to work out DE here. We've got to work out the how to get from here to there. Now, DE is quite simply along there, which is minus A, and then up there, which is 2/3 of OQ, which is OE, and we already know OE, it's this one here. So we've gone back A minus A. Notice when you're going in the opposite direction to a vector, you just make it negative. So it's minus A, and then this vector that we already know, which is 2 plus AB. So we just add that on. We've got the minus A, that's this move here, plus the 2 times A plus B, which is this part of the vector here. This is vector OE. And then we just simplify that. We multiply through the brackets to get 2A plus 2B, and then we get A plus 2B. So we know that this distance here is A plus 2B. And that is the answer for this vector move here, DE. To get from D to E, we can take this path here. So the vector is A plus 2B. Now, in the last part of the question, we are asked about using a vector method to prove that DEF is a straight line. So going from here to there is all one straight line. Now, this is a common question in vectors, and in order to prove that something is a straight line, you need to show that they have the same vector direction in space and a common point. Now, what we'll do here is work out DE, work out the vector DE, and then work out the vector EF. If they turn out to be the same direction in space and they have the common point of E, then DEF must be a straight line. Let's see how that works out in practice. So we're going to work out EQ first of all. We already know what DE is. We've got that in the first part of the problem here. We know that it's A plus 2B. So we really have to work out EF now. That's this part here. And we can see that EQ, we're told, is 1/3 of this distance here. Well, we aren't actually told it in the question. We can assume that because we know that OE is 2/3 and therefore EQ must be 1/3. And we already know what OQ is. We already know it's 3A plus B. So we're finding 1/3 of 3A plus B, and that just gives us A plus B. So we know that that distance there, that direction, that vector is A plus B. Next part we need to work out is from Q to F. We've got to add that on. Now what are we told here? We're told in the question that QF is 1/3 of PQ. It's 1/3 of this distance here, 1/3 of this vector, and we know that that vector is 3B. So it's just 1/3 of 3B. So it's 1/3 of PQ, 1/3 of 3B, which will just turn out to be B. So we have this vector and that vector. So EF is just those two vectors added together. It's the A plus B that we've got here, plus the B from there, and we get an answer of A plus 2B. Now notice that both of these vectors are exactly the same. We've got DE is this vector A plus 2B, and EF is also A plus 2B. So we know that it's the same vector, it's the same direction in space, and they have the common point E. So that allows us to state at the end that it's the same vector, it's a common point, and therefore it tells us that DEF is a straight line. Now I'm going to finish this off by having a look at what would have happened if F had been away up here somewhere, it had been further off, but still a straight line. We could have actually had it twice as far away from where it is at the moment and had a vector 2A plus 4B worked out, and then taken out a common factor to get a 2 at the front and get that A plus 2B inside. Now the important thing is the number on the outside of the bracket doesn't matter. It's this bit inside that tells us that this vector is the same as that. It's twice as long, but it's the same direction in space. Now, if we turned out to get this answer here, then we'd just be saying the same as this here. It's the same vector, same direction in space, common point, which is E, and therefore it's a straight line. That's all for this particular video. Thank you for listening.